So thank you for joining me. My background is really in optimization algorithms, and I've been spending last roughly around a decade really focusing on AI. And for last 3 years as Chief Technology Officer and Chief Architect of IBM Watson. So I'm going to take you through a journey. I'll not bore you with algorithms. I really am going to take you through a journey and explain to you why AI is different in enterprises and businesses than consumers, actually. And hopefully you will really relate to it after this talk, what is really different about businesses, why AI actually is so unique from a business point of view. And hopefully you will carry 3 points that should stick with you on why AI matters to the businesses and what businesses need to do. So here is the picture, actually. I would say nature is phenomenal, actually. By every measure, camouflage in nature is just absolutely incredible. So that picture itself, most of us will recognize that picture. However, we can get confused. If I didn't show you the top, sort of middle part of that picture, you will get confused. I think most of us will agree that's actually what is known as a stick bug. Now, that's from a computer. So where we have come in the AI journey from the point of view of computer vision is just incredible, actually, that you can show pictures like this to a computer and it can automatically recognize that's actually a stick bug with a roughly 2/3 confidence or 67% confidence. Obviously, it recognizes the olive green color with 100% confidence. However, I'll point out that AI for businesses is a lot different than recognizing stick bugs and giraffes and zebras and so on. Now, these are 3 pictures. Now, we've come to a point, again, in more what I'll call consumer AI, where given these 3 pictures, AI can start really labeling and building stories around these 3 pictures as well. So let's look at what it does. The first one is a blue boat sitting on the side of a building. Second one is a green bird sitting on top of a bowl. And third one is probably the most interesting one, I would say. First of all, it's a black and white picture. Second one, actually, it labels as a woman sitting on a table with a giraffe. Now, interestingly, you can observe that the giraffe is peeking its neck from the window. You could argue woman is not sitting on the table, she's sitting by the table. Nevertheless, it's pretty phenomenal, actually. Where we have come to is absolutely incredible. Again, I'll point out that this is very different than what we really need to deal with in real life. Now, if I were to point out 3 things that made a difference in AI, in the current wave of AI, number 1, it'll be actually compute, which was talked about by my colleague from NVIDIA, which was really enablement of very powerful compute together with very large amount of data. So basically, the rise of crowdsourcing, the rise of social media, the rise of data that came along, combined with compute and combined with algorithms, those 3 things together gave rise to the latest way of AI with deep learning algorithms and so on. However, if there was one thing I could argue that led us to the point where we are today, I would say it's actually a benchmark or a data set called ImageNet. Now, ImageNet was done by Fei-Fei Li at Stanford. She roughly had around 15 students, actually. And she basically started the job of developing a very large data set, which has approximately 14 million images. So 14 graduate students, 14 million images, 1 million images per graduate student. Now, if you start labeling it by hand, it's going to take you a long time to graduate. So she was very kind to her graduate students. So she actually undertook the first task of what I'll call now known as crowdsourcing. So she basically took that data set, which I actually labeled below, roughly around 14 million images, 22,000 classifications. This is pretty much the world around us, everything around the world, actually, for us. So she actually took that data set. She crowdsourced it to roughly slightly south of 50,000 workers in 167 countries. Now, that's a pretty phenomenal number, by the way. So that, if I just do the math, that roughly comes out to around 800 pictures per classification. So just keep that number in mind, actually, 800 pictures per classification. So let's move forward. Now, this is how we learn. So I'm going to differentiate. So I have two daughters. Now they have grown up, actually. But when my daughter was young, let's say 2 years old, me and my wife will show her a couple of pictures. A is for apple, B is for boy, C is for cat. And roughly, we had maybe 4 or 5 books. She was in love with one of them anyway, so she didn't want to see any other book either way. She only wanted one picture of a cat. And over time, you repeat it to her, C is for cat, and only one picture, and she will learn over a couple of weeks, yeah, that's a cat. And one day you show her a picture of cat she has never seen before, she will say in her cute voice, that's a cat. Now, interestingly, the way computers learn, it actually goes back to this data set. It takes computers 800 pictures to learn it's a cat versus a baby, it takes one picture to learn it's a cat. So that's the fundamental difference, and the reason I'm telling you this story is actually following. So if I look at businesses, this data set had cats, dogs, giraffes, tables, and so on. Now, if you take a bank, for example, JP Morgan Chase, Bank of America, Deutsche Bank, and so on, if you take, let's say, for example, they're trying to do risk of a financial instrument or loan processing, they're not going to take their data set and really send it out to 50,000 workers in 167 countries. It's just not possible, actually, because there are regulations, there are compliance requirements, and the banks have to be very careful. And even if they could do that, assume for the time being they could do that, there are not enough people in the world actually who know that field very well. So there are two things that are stopping them from really getting on this journey. Number one, regulations and compliance. Number two, not enough availability of that skill set. And interestingly, that data cannot go out of even a single department. Banks are actually really constrained as well. So most importantly, they are more like, almost think of it as the equivalent of babies. They need to learn from what I'll call small data because of the compliance requirement, because of the skill set not available. So they really are constrained to what I'll call learning from small data, which becomes critical for businesses as opposed to consumer area, where it's really about labeling cats and dogs and stop signs and yield signs and so on. So that's one thing keep in mind. Businesses need to learn from small data versus massive amount of data, because the way computers learn right now, or the way AI learns right now, it's about what I'll call label data. And label data is very hard to come by. There is enough data in the world, by the way. Enterprises have infinite amount of data, but they have very small amount of label data. And this is the critical part that distinguishes businesses from consumers. So there are 3 things I'm going to cover today, actually. Number one, really, AI for enterprises have 3 fundamental pillars. Number one, it learns more from less data. Number 2, it protects your data and insights, because data and insights are enterprise, really, it's their differentiator. So it needs to protect the data and it needs to protect the insights. And the third one is really about traceability, explainability, and fairness. And this is underscored in Europe more than any other place, I would say, in the world, with GDPR and early this week's announcement of AI ethics guidelines. So those 2 things, I think Europe is leading the world in terms of how AI needs to be managed and how AI needs to be really accountable and traceable as well. So those 3 things are the one which are really guiding principles for AI for enterprises as we move forward. So let's talk about learning from less data. So let's look at some quantitative numbers, actually. Now, this is what is known as a learning curve, by the way. So most of you actually, so think of this as an IQ, actually, for AI. On the x-axis is actually number of training samples. So if there was an AI model, you actually give it certain number of training data. And the y-axis is the accuracy, by the way. So you will see numbers like 88%, 90%, 94, and this is 98%. So what I'm showing you is, so where we at IBM, we have focused on is really this aspect of, because Watson is really meant for AI for businesses. That's really the stake in the ground for us. This is where we've been driving it for the last 5 years. And the data that you are seeing here, actually, this was done really by an external startup. We stumbled upon this data. We didn't actually create this data. We stumbled on it, and it's really done from an independent point of view. On the x-axis is the number of examples it takes. On the y-axis is the accuracy, as I said. And Watson itself is this top curve. All the other capabilities available are basically this band right here. And you can see that if I wanted to actually achieve an accuracy of, for example, 96%, if I draw a horizontal line of 96%, you will see that Watson needs roughly around half the data it takes than any other actually capability available out there. And this is not by actually fluke. This is the way it is designed from algorithms and architecture from ground up. Happy to cover it after the session with anyone who is interested in learning details. But it's really about the first point that I stated. We built the architecture of Watson with this in mind so that the time to value for enterprises is higher. So that's the first point. We are not happy with just, hey, Watson can learn from 25 data samples. We really are pushing the limits in terms of research, looking at, in academia, what is known as few-shot learning or one-shot learning. By that, I really mean if I just gave you one example, how much can you learn? So we are at a point right now where if I just gave you one example, we can achieve roughly around 95% accuracy. If I gave you 5 examples, we can achieve around 98% accuracy. And these are things that we are pushing in our research labs, again, with the point of view that Watson and AI for businesses needs to be good at learning more from less data so that the time to value for the enterprises is higher. Let's look at the second one, which is protects your data and insights. So if I really look at all usage scenarios of AI in enterprises, enterprise knowledge in, for example, healthcare, insurance, accounting, consulting, manufacturing, telecom, retail, natural resources, manufacturing industry, and use cases like customer care, regulatory compliance, risk assessment, discovery and insights. That really is a fairly broad area. However, as I talked about time to value for businesses, nobody should be teaching the AI sort of things around the world. For example, knowledge like Wikipedia. The AI should come smart out of the box. And the way actually AI for business architectures need to be built is actually following. So if I'm showing you what I call a 3-layer cake or a 3-layer architecture. The way Watson is built, the way we built Watson, right from ground up, is basically following this fundamental architecture, which is the bottom layer is what we call a base AI model. Think of it as Wikipedia kind of model, actually, which is Watson should understand the world around it. It should come smart out of the box. The second layer is actually what I'll describe as industry or domain model. For example, nobody should be teaching a AI operating in a finance industry. What does it mean to operate in a finance industry? There is certain common knowledge across that industry, whether it is Bank of America or Deutsche Bank or JP Morgan Chase. There's certain lingo that exists in the industry which AI should really know. So that's the second layer. And the third layer is really, that's your data. That is, again, Deutsche Bank, that's Bank of America, that's JP Morgan Chase. It could be insurance industry. So that's really your data and your insights. And the way this architecture really works is actually the transfer of knowledge takes place from the bottom to the top. And your knowledge and your insights are really protected in this particular layer, which is isolated from the rest. And the knowledge transfer takes place from the bottom to the top. So these 3 layers work hand in hand to give rise to what I'll call one of the most efficient architectures that exist for AI for businesses, which is really about AI should come smart out of the box. It should understand the world around it. AI should really be understanding the industry I operate in, and I should be able to customize it to teach my knowledge to that particular AI as well. So that's really the fundamental of how actually Watson works and how any good architecture, which is really AI for businesses, should work as well. Let's look at the third one, which is probably one of the most critical one, given how wide an impact AI is having. So roughly, I think this is the study that was done by IDC. 94% of the companies believe that AI is critical to their strategy. However, only 1 in 20 are incorporating this as part of their workflows. So what's stopping it? So roughly around 60% state, this was again a study done by IBM Business Values Institute. So roughly around 60% say that compliance issues regarding to be able to explain the decisions of AI, and issues regarding fairness of AI is really stopping them from putting it as part of their critical business processes and critical business workflows. So we actually really took that, and we are at the leading edge of this among all the players in this area, and really incorporated it as part of some of the product offerings available from us directly that you can really go and try out as well. So it really gives rise to this notion of trust and transparency for AI. Again, I think Europe is at the leading edge of it with respect to GDPR and the latest this week's actually announcements of ethics guidelines. So AI should be able to detect bias. It should be able to automatically detect bias because, so there are two things actually. One is when an AI model is built, the data scientists can really go and analyze that model for bias. That is the exercise that they do already. However, the way these AI models are built, they are built with what is known as training data. Now, interestingly, training data is only a representation of reality. It is not a reality in itself. There is only one reality. When that model is really working in real time, that's the only reality that exists. That is the only golden truth. Everything else, I would argue is a representation of that reality. And it is critical for AI to be able to analyze for bias when these AI models are making decisions in real time, right at that time, not by the data scientist on the side in a lab, but at the time when these decisions are being made. And the product that we have actually announced called Watson OpenScale really does that in real time. Second one, AI should be not only able to detect bias, it should be able to mitigate that bias as well. And we have brought together some unique technology. Think of it as AI correcting AI, actually. So rather than AI really working in isolation, it's about AI correcting AI. And we've got AI algorithm that really can detect that bias and also automatically mitigate it as well. Again, the next step in that journey. The third one is really about AI should be able to explain its decisions in plain English terms, not for a PhD data scientist, but really for a business process owner. And again, you should go take a look at, you can Google Watson OpenScale. It'll actually give you a very good overview of what this is really about. But think of this as I'm explaining a transaction right here. Why was my claim denied? Your claim was denied because your policy age was less than 1 year. The weightage of that was 45%. Your claim frequency in the past has been high. The weightage of that was 32%, and your age is actually 18. So that actually also weighed in with 14%. And there were some things that were going in favor of that transaction being approved as well, which is also given here. Again, all in plain English terms, and your transaction was denied with a 90% confidence rating. We don't just stop there. We actually even tell you that what are the minimum amount of changes you need to do to your application so that your outcome can change from denied to approved. So all else being equal, if your policy age was between 2 to 3 years rather than 1 year, and if your claim frequency was low, everything else being same, your transaction would have been approved. It's like me as a consumer calling and really asking, what do I need to do to really change the outcome of my transaction? And the last one I would say will be, and I'm just going to show a 30-second clip of a video. This is really a breakthrough in how AI is actually built. And most of us would know the skills needed for building latest and the greatest of AI is very high. Roughly, in Silicon Valley, it actually cost $2/3 of $1 million to actually hire skilled workers in this area or skilled data scientists in this area. Now, we have brought together technology where AI can build itself. And really, this is comparing the algorithms building AI with respect to hand-tuned capabilities as well. And what I'm going to show you is a video, actually, which is a compressed video. So rather than really taking thousands of GPUs, it actually is just working with one GPU to be able to design a latest and the greatest of AI models. Again, this capability is available for you to try out as well. And what you're going to see is on the left-hand side, some accuracy numbers it starts from. And on the right-hand side, the way the architecture of neural networks is changing and it's evolving, and then gives you a automatically designed neural network, which is really optimized for the task at hand, all automatically. It just doesn't take 20 options that are pre-packaged and pre-canned and figures out what is the best. It literally builds a neural network from scratch, absolutely from scratch, actually, with some very unique algorithms that are built for designing those neural networks. So you see the accuracy numbers here. It actually starts from roughly around 85%. That is creeping up. It's really evolving that architecture all automatically. And finally, you can see these numbers, these design points changing. It literally is evaluating hundreds and thousands of options as it is going through all of these capabilities. This run roughly took around 6 hours. But this is really a compressed version of it. Typically, all these runs take roughly around overnight. It's available for both text domain as well as image domain as well. And you see, when it is all done, it actually is an accuracy of around 93% with a precision of 94% and a recall of 92%. It's really AI designing itself, which is, again, a breakthrough in how we really are addressing the problem of skills gap in this area for, again, AI for enterprises, because there are not enough skills to go around. And the last one I'll leave you with is what lies ahead for AI. It's really going to be about AI everywhere. I am personally convinced it's going to really percolate through every industry you can think about, from financial crimes to underwriting to investment planning to risk modeling and so on. Deeper insights. So it's really about distributed AI, machine foresight, cognitive discovery, learning and inferencing, and then engagement reimagined from really point of view of augmented reality, and personalization at scale, and finally, instrumented planets. So I'll leave you with that. Thank you very much for your time, and I appreciate it.
Thank you.